Okay, good day. My name is Dennis Pegden. I'm CEO of Simio, and we're bringing to market a new simulation product called Simio that we introduced at the recent Winter Simulation Conference. Many of you were disappointed that you didn't get to see that introduction, so we've recorded it for you here. Okay, so a little history on Simio. We started in 1205, and we're committed to changing the market. By changing the market, we want to make simulation easier to use. We want to expand the scope of applications for simulation. At the end of the day, make it a better decision-making tool. Although we're a new company, we have a very experienced team. Our team has over 80 years of experience in bringing market-leading products to market, including the Arena product that many of you may be familiar with. We're also looking for your involvement, and I'll say more about that towards the end. To understand Simio, it's important to understand the notion of modeling views. In the history of simulation, there have really been three main modeling views: the event view, the process view, and the object view. In the event view, we model the system by describing the points in time when the system changes, and then model the logic with each of those associated changes. In the process view, we model the system from the point of view of an entity that moves through the system and describe the process as in form of a flowchart. And finally, in the object view, we describe the system from the objects that make up the system. Although all three of these views were present from the starting point in simulation, originally the event view was the only view that was initially used. And it really became the go-to method during the first 20 years of simulation modeling. The vast majority of models built during this period were built using the event orientation. Starting in the 1980s, the process orientation really took over. It replaced the event orientation because it was just as flexible, efficient, and scalable, but it was much easier to use. The process orientation has really remained in use since that point, and today most models are built with the process orientation. Although the object-oriented view has been around for 50 years, and has been used in some applications, it still hasn't reached general acceptance. In Simio, what we're really doing is looking at the object view and seeing what we can do to bring it into general acceptance, because the object view is the most natural and easiest to use of all. Just a little history on the object-oriented modeling. First of all, it was invented for simulation. The simulation tool called Simula was the first object-oriented programming tool in the world. The basic concept of object-oriented is that you have classes that define behavior for objects. And then those classes are placed together in your model, and the system behavior really emerges from those objects interacting. The challenges with the object approach is that to have a really flexible tool requires a notion of user-defined objects. That is, the user needs to be able to create their own objects and add those to the library of objects that they have. With existing technology, you're stuck with either one of two things. Either you have a fixed set of modeling objects that you can't change or add to, or if you are able to add to them, you have to add to them with event-based programming. So you end up programming in a language such as C++ or Java in order to be able to add new objects to the library. The Simio solution takes a different approach. It's a new and unique modeling framework. And the core idea is that in place of program event code, we have processes. So processes replace user-coded methods. As a result, new objects are easy to build. So we combine the flexibility of being able to add new objects and the ease of use of an object-based tool. This makes simulation easier for decision making. So the Simio object concepts, let's review them. First of all, objects become the building blocks for models. You build models by taking objects, placing them into your workspace to represent the physical components of the system. Objects can be user-defined, and they bring along intelligent behavior. The objects, again, interact to really define the behavior of the system. We provide a standard library of objects as a starting point. But those objects are just a starting point. You can build your own objects and add them to libraries to model different types of systems. Objects can be extended and easily added, as we'll see here in a minute. There are 6 basic object types in Simio. The first one is a fixed object, and it just has a fixed location in the system. An example of a fixed object would be a machine that stays in one location in the system. A link is a different type of object that models a pathway between objects. So links might be, say, AGV pathways, conveyors, road systems, and so forth. Nodes provide intersections between links. So they model the logic that takes place as entities move from one link to the next. Agents are a type of object that's dynamic, that moves through the system. And agents can move through free space. The next type of object is an entity that is subclass from an agent. That means it has all the same behavior as an agent, but in addition, it can move across links and enter into other objects. And then finally, a transporter, which is subclass from entity, can pick up, drop off, and carry other entities. So examples of transporters would be carts, AGVs, and so forth. Okay, with that as a brief introduction to the concept of Simio, let's jump into the software and take a look at what it's like to build an actual model. So we're going to start off building a very simple model. This simple model just has 3 objects. It has a source object that creates entities, sends them to a server object which models the service process, and then finally sends them to a sink that models the departure from the system. Okay, before we build this simple example, let me just spend a minute describing the user interface that we're looking at here. If you notice across the top, we have what are called ribbons. Ribbons are the latest Microsoft technology for user interface design. Each ribbon has a set of controls on it. For example, the Run ribbon has a set of controls related to running the model. Along the left side, we have the standard library. And the standard library is a set of objects that comes out of the box with Simio that you can use to build models. In our example here, we're going to use objects from this standard library to build our model. And we'll start by selecting the source object, and we'll drag it out into our workspace. The next object we'll choose will be the server, and we'll drag the server out and place it also. The server is going to model the service process that takes place as entities move through the system. Then finally, we'll pull out the sink object and place it down here. Now we'll use objects called paths to connect the source to the server. And then we'll use another path to connect the server to the sink. And at this point, we're ready to start running the model. So we'll go to the Run ribbon, hit the Run button, and we see entities moving through the system. Now while the model is running, we can move things around. So we don't have to stop the model to edit it. We can shorten the path from the server to the sink, or we could come over here, add a new path that goes from the source down to the sink, and as soon as we add it, it will start using it. And by default, it's just going to randomly select between those 2 paths, but you can put in other rules to control the actual flow. So as you can see, in just a few minutes, a simple model like this we can build by just simply dragging out the objects, connecting them together, hitting the Run.